Let's solve rotate image problem from LeetCode. Before explaining this problem, let's see what are the companies they ask the questions. So you can see this is a list of the companies they asked the question. Okay, let's understand this problem. There is a matrix, two-dimensional matrix, and in this matrix we need to rotate by 90 degree. So if you see, if you 90 degree and the clockwise direction, then if you rotate this 1 2 3, this 1 2 3 comes here, and then 1 2 3 6 6 9, and if you see 6 9 and 8 7, so 6 9 8 7, if you see 6 9 8 7 and 4 5, so that's a rotated. So, and there is some constraint given here. You have to rotate the image in place. That means we do not have to use any additional space, or so we have to do in place. So that's the requirement. So the question is, first we need to understand, even though like if you use the additional space, how to do that, and then we'll think about doing in place. So let's understand this algorithm. We need to do a little bit pattern analyzing here, and then after that we can solve this problem easily. So I'll jump to the another screen here, and I have put the same example here. There is approach 1 and approach 2. We'll come to the approach 2. For this I will write the code, and for this is very easy, you can do by yourself. But let's see, 1 2 3 4 5 6 7 8 9, 1 2 3 4 5 6 7 8 9, and this is the result we need: 7 4 1 8 5 2 9 6 3. And if you analyze this data, so 1 2 3, and this row is here column 1 2 3, and if you see 4 5 6 closely, so 4 5 6, see, it's a column. 7 8 9, 7 and 9, it's a column. So this row is becoming column here. And I just took the example for 1 2 3 here. So for this 1 2 3, and for the 1 2 3 I took its location. So 1 is at 0 0 location, this is a 0 1 0 1 2, and this 3 is 0 2 location. So that's the location for 1 2 3, because this is the our normal way to traverse this data, because we first will come here. Usually we use the two for loop, and then we'll come here, go here, go here. So that's why I have written 1 2 3, and this is the location 0 0 1 0 1 0 2. And for the same 1 2 3, I want to see what is the location of the 1 2 3 in a this transform form, like when we transform or rotate this by 90 degrees. So in this place, what is the location for 1 2 3? So for this 1 2 3 here, if I see, this is the 0 row and 2 column. It's a third column, but by index we say 2, so that's a 0 2. That's location is 0 2. If I take this one, the location is 1 2. If I take this one, then location is 2 2. So we need to do the math here, and then we can easily do this work using extra space. So if I create M2 another space, then how we can do? So I need to find out some pattern here. So if you see, this is for same thing. It's like 1 2 3, and this for also 1 2 3. Let me put together here, and I'll just move a little bit this one. Yeah, so for 1 2 3, this is a normal way of traversal, and here this is in our target value. So if I create a new M2 matrix, 2 by 2 dimensional matrix, and if I do the normal for loop, then in a normal for loop, how can I achieve here? So I traverse normally with the ij, and then in a destination, if I can put M2j here first, Then what is the j? So first we want to put the I, so the I in ith place, this is j. So j is, if you see here, 0 1 2. So the j is changing 0 1 2, but this is actually put in a I location. So I put the j here, and for this 2 is n minus 1 I. If I put this logic, then I can easily achieve this. So simply I have to do for I is 0, I less than what is the aim, or so that's just a pseudocode, I plus plus, and then for j is equal to 0, j less than n, j plus plus, and then come here, and then in this case I can do new matrix j n minus 1 I, and our original matrix I j, and we can get the solution here. We get a new matrix, we'll have this transpose data. So yeah, that's a not a transpose, but we can say transform data in a by 90 degree. So this is the formula we need to figure out here, because we know this is I is changing here, I is changing, so that's why, and I is nothing but here due to the j, so that's I put the j here in ith place, and that's the logic. If you can figure out, you can solve easily. Okay, so that's the one solution, but we are not supposed to put that solution here, even though if you put that will be accepted, but we want to solve this in a in place. So let's understand how will you do in a in place. So for 1 2 3, if you see here in approach 2, 1 2 3 we have done the transpose of the matrix we have done in place here. So this 1 2 3 become 1 2 3 row, 4 5 6 row, 7 8 9 7 8 9 row, and then what I did, I reverse each row and I get 7 4 1 8 5 2 9 6 3. So first I transpose first step, and second step reverse each row. So if I do that, eventually I get this target 7 4 1 8 5 2 9 6 3, and we'll be able to rotate by 90 degrees clockwise direction. So that's the approach I'm going to use here. But when I transpose this matrix, normally, and when we transpose the matrix, we'll run a for loop, and then what we do, we usually do j is equal to 0, exactly same thing, and then here we can do ji and equal to here ij. So that's a normal transpose matrix. But in this case, in this case we need additional space also, but we do not want to use the additional space. So in that case we have to use another approach here. When we do the transpose matrix, we can see here like 2 4, we exchange this 2 4, we exchange here. You see here 3 7 7 3 and 6 8 and 6 8. So we just exchange this value here to here. We can just say swap. We just swap the value in a diagonally. So we are swapping the diagonally, and the diagonal swapping is only possible in a square matrix. So we can use that technique, and when we use that technique for this, then usually the way, instead of j0, if I just put j is equal to I plus 1, then that logic works here. So I assume you can write this thing, you can try by yourself. When we try, you can create another matrix, and you put the data in another matrix, and then assign that value again back to this matrix, because we are not returning anything, we are changing in place. So we can achieve this way also, but here we have to use additional space, and in this approach we do not have to use additional space. So let me write the code for this. So first of all, I will transpose the matrix. So for I is equal to 0, I less than length of matrix I plus plus. For j is equal to, I'll do simply I plus 1 because I'm swapping diagonally. J less than length of matrix I j plus plus. Okay, and when we swap the two value diagonally here, then either you need a temporary variable and you can store this in a temporary variable and then you put that here and again swap that. You can do that, but in a Golang it's a very we can remove one step. So it's a eg here it has done. So what I do, a that's a matrix, and matrix j I, matrix I j, matrix I j, matrix j I. So in this way I can easily transpose, because I'm saying in a ji I put the ij, and in a ij I want to put the ji. So if you want to use a temporary variable, you can do that way also, but I'm using this way. So in this way we successfully transpose this. Okay, now next thing is we have to reverse that value here. So now we got like 147, 258 and 369. Now each row go and reverse this in each row, and that will get the final result. So for the reverse, again I is equal to 0 length of matrix and I plus plus. So we get each row here, and now we want to reverse. So for this reversing, I know we have the row here. Now for the reversing, I'm going to use the 2-pointer. So I'll say j is equal to 0 and the k is equal to length of matrix I. So that is my k and minus 1. So that's for each row starting with the 0 and then k at the end. So I'm putting the 2-pointer here. Now I'll run a loop for j less than k, and then we can use the matrix I, that is the row, and in the row I'll put the j column, and again matrix I, same here k. So I'm not using any additional temp variable, so that's why I'm using the exactly same technique. So matrix I j comma matrix, so ij, so first one I, so this should be ik, because this value ik should be in ij, and then ij should be here. Okay, so in this way ik value, the ik is the last value in the same row, last value in the same row goes to the same row first value here. Okay, and then the first value go to the last row. So in this way we'll be able to reverse this, and then we can do the j plus plus and the k minus minus. Let's run this, accepted, submit. Okay, so that's all for now. Thank you.